Okay, so to take a look at a couple of word problems, we're not going to do everything in here, but take a look at problem number 1. Just read it. Don't do any math yet. Just read the thing. We looked at things like this earlier in the year with the intermediate value theorem. We have our position. Could you guarantee that somewhere the position of the car will be 10? The position. Sure, probably between 10 and 20. Can you guarantee somewhere the position of the car is going to be 22? Where? Because we can't just use the endpoints there, but looking at what? Done. Between 30 and 40, somewhere the position has to be 22 because it has to be continuous. Can we guarantee somewhere the position will be 35? Could the position be 35? Okay, this is nothing new. But now I want to try to guarantee something about the speed. Speed or velocity, that'll also kind of work here. How do we get velocity from position? Manoj? Slope of the position, also called the d, or the derivative. Basically, I want to try to guarantee, I want to figure out the derivative that is guaranteed to happen somewhere. Well, this is all about the mean value theorem. Between 0 and 20, what must the speed have been somewhere? Well, let's find the slope of our secant line. Let's find s of 20 minus s of 0 over 20 minus 0. The distances are in miles, the time is in minutes, so 7/10 miles per minute. I don't know when exactly I'm traveling at that speed, but I know at some point between time 0 and time 20, that has to be the speed of the car. Does that make some sense? Go do letter B. And you know what? Then take a look at letter C as well. Hopefully 11/20 miles per minute. We're not going to do this right now, but I'm assuming you could convert this to miles per hour to make things make a little more sense. What's going on in C? Only one person can tell me? Only 3 people can tell me? Casey, what's going on? Well, okay. So what speed is guaranteed? 0. Which means what's going on? Manoj. Yep. I don't know where exactly, but I know somewhere between time 30 and time 60, the car must be stopped. Any questions so far? Do you see how we can get these from a table? Again, we're not trying to prove where exactly this happens, just to prove it will happen somewhere. Somewhere this will be our speed. Somewhere this will be whatever. On the next page, I'd like to take a look at this with you. There's a little bit more to this problem. Please just read the paragraph at the top. Part A. Is there some time where the velocity has to be -5? Well, I'm given the velocity. Can we just look at that velocity row and know that somewhere the velocity has to be -5? Why? By the mean value theorem? Not at all. By what? By the intermediate value theorem. We're asked to justify our answers, so we need to kind of write this thing out formally. That's really what the justify part means. Well, okay. Do we know if the velocity is continuous? Why? It told you. If it didn't say that, we wouldn't really be able to guarantee that somewhere the velocity is -5. So I do need to make sure I reference that, because v of t is continuous on the interval between 0 and 60. And v of 0 equals -20, and v of 60 equals 10 by the intermediate value theorem. V of t must equal all values, bless you, between -20 and 10. Specifically, somewhere v of t equals 0. Nope, I don't care about that. Specifically, somewhere v of t equals -5. That's the one I was trying to guarantee. Letter B. Can I just look at the table of values for my accelerations and guarantee that somewhere the acceleration is 0? I don't think so. I can guarantee any acceleration between 1 and 5, but not necessarily 0. However, there is still a way we could do part B. I can guarantee that somewhere the acceleration is 0 by looking at my velocities. How's acceleration related to velocity? It's the what? Slope, derivative, all that stuff. Casey, your hand was up a moment ago. What were you going to say?
I was going to say that since it goes from -20 to -20 the velocity, then that means that the acceleration is going to cross the x-axis if it were that.
Yeah, so really we're talking about the mean value theorem here. I want to apply that mean value theorem to my interval between 0 and 25. First of all, before we apply the mean value theorem, we have to state we're allowed to use the mean value theorem. Is velocity continuous between 0 and 25? V of t is continuous on the interval 0 to 25. Is v of t also differentiable between 0 and 25? How do you know? It told you that. It said we're differentiable. So v of t is differentiable on 0 to 25. So, the mean value theorem applies. Somewhere, the slope of velocity, which is the acceleration, has to equal, well, v of 25 minus v of 0 over 25 minus 0. Negative 20 minus negative 20 over 25. Yep, somewhere that slope has to be 0. Intermediate value theorem guarantees things about y values. Mean value theorem, though, guarantees a particular slope will happen on your graph. Hannah, you look a little confused. Are you sure? Yeah, we can't prove anything from the acceleration line, but we can prove it from the velocity. Prove something about its derivative. Quasi.
So we can prove it from the velocity because we went from negative 20
Yes. So basically, I'm finding the slope through these 2 points. Well, slope has to be 0 because the y values are the same. Do I want to do anything else with this? Very quickly, let's take a look at number 3. I want to prove that somewhere the rate of change of the temperature is 10.6 degrees Fahrenheit per second. I'm looking at the temperature function. Is temperature something that's continuous? Didn't state that here, but if something is being placed in boiling water, temperature can't jump from like 100 down to 50 or up to whatever. Temperature is continuous because the temperature, I'll call that T of T, is continuous, and it's also differentiable, which means there are no sharp changes in temperature. Somewhere, the rate of change of the temperature has to equal, well, the temperature at the end minus the temperature at the beginning over the change in time. Do we know the temperature at the end? A what? Like what? Temperature at the beginning? Pretty sure that's going to be 10.6 degrees Fahrenheit per second. Quasi.
So if the problem is it suddenly changes to 212, is that when say it's not differentiable?
It can't really do that. Temperature can't work that way.
But let's
Yes.
Okay.
Then you wouldn't be able to. With these word problems, you're always going to be able to do things. Can I prove somewhere that the temperature was rising at 10.8 degrees Fahrenheit per second? Not necessarily. This is the one rate that I can guarantee by the mean value theorem. There's another theorem we have to talk about, and I only have like 8 minutes, but I think we can take care of this in 8 minutes. This is called Rolle's theorem. This is really just a special case of the mean value theorem. What I would like you to do is draw a small graph. You are going to draw something that is continuous and differentiable, but also the y values at the endpoints must be equal. So I'm going to put an endpoint over here. I'm going to put an endpoint over there. Draw anything continuous and differentiable through those 2 points. As simple or as complicated as you want it to be. make mine pretty simple. There's my function f of x. According to the mean value theorem, what slope must occur somewhere on the graph? Is that a hint, Julia? Sabrina? 0, right? Does your graph have a place where the derivative is 0? Mine does. Rolle's theorem basically adds in an additional requirement. It says if the y values at the endpoints are the same, then somewhere the slope isn't just calculated by this formula. Somewhere the slope has to be 0. Here's what Rolle's theorem says. 1. If f of x is continuous on our closed interval from a to b. 2. F of x is differentiable on our open interval between a and b. And 3, there's a new requirement now. And f of a, bless you, equals f of b. Bless you. Then, somewhere, the derivative must equal 0. Or our more formal way of saying it is there exists a c value such that f prime of c equals 0. We've actually already used this Rolle's theorem. We just didn't call it Rolle's theorem when we looked at the graphs and tried to find places where the slope was 0 because the y values at the endpoints were the same. We are going to try to apply Rolle's theorem to the function f of x equals x squared minus 3x plus 3 on the closed interval between 1 and 2. I want to try to apply this new theorem to that function. The first two things you need to check are the exact same things as in the mean value theorem. Make sure that thing is continuous, just state it. Find the derivative, make sure the derivative is continuous, so the original function is differentiable. In the homework, do not just start finding derivatives and setting things equal to 0 or various other values. You first need to actually explicitly go through the checks. I will be looking for that. And I'll definitely be looking for that on your test. So I think you should be starting the exact same way we started with the mean value theorem. But there's another thing I do need to check now. I need to find f of 1, which is 1 minus 3 plus 3. That's 1. And I need to find f of 2. That's 4 minus 6 plus 3 equals 1. Quasi.
You said negative 1, 2, instead of 1.
Thank you. Positive 1, 2. Yeah, those values were the same. Does Rolle's theorem apply? Sure it does. Somewhere, what must the slope be? 0. Somewhere, not just somewhere, somewhere on that interval 1 to 2, the slope is 0. Well, next part, go find it. Figure out where the slope is 0.
While you do this, let me get the homework pass out.
We're not going to bother with a quiz on this stuff. It'll just show up on the test. And I focused way more on the mean value theorem stuff than on the Rolle's theorem because really it's just a special case. Honestly, you could do all the Rolle's theorem problems with just the mean value theorem. The slope you'll calculate is 0. And please pass up the rulers. They are. They came in 800 of them. Talk tomorrow morning. 800. Okay, so hopefully you're able to finish this one off. I'm going to set my derivative equal to 0. Where is the slope 0? 3/2. There are some problems in the homework where Rolle's theorem doesn't apply. If you're not continuous, you can't guarantee the slope's going to be 0. If you're not differentiable, we can't guarantee the slope is 0. Those two things might hold, and the y values at the endpoints might be different. If they're different, bless you, can't guarantee the slope is 0. We didn't go through any of those examples, but I think you can figure that out. And that is all I think I have to say about things. Quiz tomorrow on 3-6. Again.